Bisection method. Bisection method is root finding algorithm, also known as Bolzano's method, binary chopping, and internal halving. When using bisection method, there is a condition. If the function changes over an interval, the function of value at the midpoint should be evaluated. The algorithm on this bisection method is then choose the lower limit and the upper limit guesses the root such that the sign changes over an interval. This can be checked by multiplying the function of the lower limit and the function of the upper limit is less than 0. Number 2, an estimate of the root of the midpoint of the x is determined by the equation the midpoint of the x is equals to the upper limit of the x and the lower limit of the x over 2. Number 3 is make the following evaluations to determine in which subinterval the roots lies. A. If the function of the lower limit multiplied by the function of the upper limit is less than 0, the root lies on the lower subinterval. Therefore, we set that the midpoint of the x is equals to the upper limit of the x. Then return to step 2. B. If the function of the lower limit multiplied by the function of the upper limit is greater than 0, the root lies on the upper subinterval. Therefore, changing the lower limit of the x is equals to the midpoint of the x. Then return to step 2. C. If we multiply the function of the lower limit multiplied by the function of the upper limit is equal to 0, the root is equals to the midpoint of the x. Terminate the computation. In this segment, we will have an example. We are given a function, the x cubed minus 25, and we have set the lower limit as 2 and the upper limit is equal to 3. Now, find the roots of this function using bisection method after 3 iterations. Now, we have put this function, our answers in a table so that we can compare easily our answers and impose our algorithms in the bisection method. Now, we have the equation of the midpoint of the x as the lower limit of the x plus the upper limit of the x over 2. Now, we will solve it. 2 plus 3 divided by 2. We now have the midpoint of the x as 2.5. Now, in the function of the lower limit, we will just substitute our lower limit on the x. Now, 2 raised to 3 minus 25 is equals to negative 17. Now, we have a function of the lower limit. Now, we will substitute our upper limit in the function. Thus, 3 raised to 3 minus 25, we will get the function of the upper limit as 2. Now, we will substitute our midpoint of the x to the function. 2.5 raised to 3 minus 25. Now we have the function of the midpoint of the x, negative 9.375. We will just leave our approximate error because we don't have the previous value of the midpoint of the x. Now we will proceed on the first iteration. Now, remember that we have the algorithms of a bisection method. If we multiply the function of the lower limit multiplied by the function of the midpoint of the x, if it is greater than 0, we will set our midpoint of the x to the lower limit. And if it is less than 0, we will put the midpoint of the x to the upper limit. Thus, if it is now, when we multiplied function of the lower limit multiplied by the function of the midpoint of the x, it is greater than 0. Now, it is said on the algorithm that we will substitute our lower limit, or we will set our lower limit as the midpoint of the x. Now we will use 2.5, the new 2.5 in the new lower limit of the x. Now we will just retain our upper limit. Now get the midpoint of the x by using the previous equations. 2.5 plus 3 divided by 2. We have now got a new value of the midpoint of the x, 2.75. Now we will substitute our new lower limit to the function, thus getting this, negative 9.375. Still, we will just retain our function of the upper limit because it is the same. Now, the new midpoint of the x, we will substitute it in the function. 2.75 raised to 3 minus 25. We now got a new function of the midpoint of the x. It is negative 4.2031. Now we will get this approximate error. This the approximate error is, we will just the present value minus the previous value over the present value of the midpoint of the x times 100. So we will calculate it. 2.75 minus 2.5 divided by the present value of the midpoint of the x, 2.75 times 100. Now we got the approximate error of 9.0909%. 9.0909%. Now, examine again the logarithm of the function. We will now multiply the function of the lower limit multiplied by the function of the midpoint of the x. It is still greater than 0. Now, we will now set the midpoint of our x to the new lower limit, which is 2.75. We will just retain 3. Now we will get the new midpoint of the x. 2.75 plus 3 divided by 2. We have now get the new value of the midpoint of the x, 2.875. Now we will just copy this in the function of the lower limit, negative 4.2031. Still the same in the upper limit, function of the upper limit. Now we will get this new function of the midpoint of the x, 2.875 raised to 3 minus 25. We now get the midpoint of the x as negative 1.2363. Now we will get another approximate error. The present value, which is 2.875, minus the previous value, 2.75, divided by the present value, 2.875 times 100. We now get the new approximate error, which is 4.488%. That is how we calculate the roots of the bisection method.